Hello and welcome to our workshop. I'd like to introduce myself. My name is Scott Parker, and on behalf of the University of California Cooperative Extension in San Diego County, I want to thank you for joining us today. It's my extreme pleasure to introduce today's speaker, Carolyn Kinnan. Carolyn is an environmental horticulturalist and has been an instructor at Miracosta Community College Horticulture Department for many years and is currently the instructional associate for the department. She is a Bachelor's of Science in Environmental Horticultural Sciences with an emphasis on integrated pest management from one of the premier agricultural institutions in California, Cal Poly San Luis Obispo. Carolyn has been working with the Healthy Garden, Healthy Home program since its inception in 2005 and has given more than 100 lectures and developed more than 24 educational modules. Many of those can be seen on our UC Healthy Garden, Healthy Home website. It's my pleasure to turn our program over to Carolyn Kinnan. Take it away, Carolyn.
Thank you, Scott, and good morning, everyone. Thank you for joining us. As Scott mentioned, this is a new workshop. I'm very pleased to be presenting it. I enjoy working with irrigation, and it's very satisfying when you get your irrigation system dialed in. So I'm hoping the workshop will be helpful to you today. I want to ask you to forgive me for referring to my notes because it is a new workshop. I want to make sure I get all the information in that was intended. So to start, I want to tell you about the Healthy Garden, Healthy Home program. This program is a cooperative effort between the University of California and the County of San Diego Watershed Protection Program. And the program is designed to inform San Diegans about watershed pollution and how we can utilize and implement best management practices in our home, gardens, and landscapes that reduce that pollution. At the same time, Healthy Garden, Healthy Home provides information that's useful to us in maintaining beautiful gardens. So again, we hope the presentation today will be useful to you. First, however, I want to emphasize the importance of managing irrigation to avoid runoff. All San Diego residents live in one of 11 watersheds, and the accumulation of irrigation runoff from our lawns and gardens is a major contributor to that watershed pollution. The materials that pollute the watershed include pesticides, fertilizers, herbicides, soil sediment, and because those materials are carried directly to the storm drain and onto the watershed without mitigation or treatment, the pollution ends up in the watershed. So this results in a reduction of our quality water supply, a reduction in recreation, and threatens our wildlife and estuarine habitats. To show you then how easily these materials get into the watershed, I want to illustrate with an excellent video that specifically looks at San Diego's watersheds. The video is about 3 minutes, and then we'll begin the presentation again.
Have you ever been walking along a quiet beach without a soul in sight and suddenly stumbled across a pile of trash? You've probably asked yourself, where did all this garbage come from? There's hardly anyone here. The truth is, it may have traveled a further distance to get to the beach than you did from your home. You see, when water moves downstream, it carries with it things you can see, like plastic bags and cigarette butts. It also carries things you can't see, like pesticides and fertilizers. Even though it's not as obvious as the trash, pesticides and fertilizers that get in the water can hurt the small animals and plants that live there. But I'm getting ahead of myself. To understand how these pollutants got to the beach, we need to know a little more about a thing we call a watershed. What is a watershed? Well, basically, a watershed is a geographic area that drains to a common water body, but it's so much more. Each watershed includes an ever-changing system of water bodies, such as streams, creeks, drinking water reservoirs, lakes, estuaries, bays, and in most of the watersheds in San Diego County, the Pacific Ocean. In San Diego County, we have 11 watersheds that drain west towards the Pacific Ocean. The waterways in these watersheds provide San Diego County residents with water for a multitude of uses, including our water supply for drinking and industry, irrigation for landscape and agriculture, support for wildlife and estuarine habitats, and recreational activities. Remember the trash on the beach? It was probably carried there through the streams and storm drain systems within the watershed. Ultimately, trash, pesticides, fertilizers, and even soil from erosion will reach our beaches, causing an unsightly and toxic mess for residents and wildlife. So wait, let's look at that again. The water in the ocean comes from the streams and creeks, and the streams and creeks pick up runoff from the land further upstream. So that means if I spray pesticides on my lawn in Lakeside, use too much fertilizer on my tomatoes in Fallbrook, or throw a bottle on the ground in Bonita, these materials can run off my property, flow down my street, enter into a storm drain or stream system, and then end up in the ocean. Remember, if you spray something in your garden or on your landscape, there's a good chance it could end up at the beach. So what happens if this waste and pollution ends up on the beach? Trash on the beach can not only dampen our fun, wildlife can become entangled in it or swallow it. Even though fertilizers and pesticides are not as visible as trash, they also have a big impact on the health of the watershed. With more than 3 million people in San Diego County, can you imagine the amount of waste and other pollution going down our watersheds? You get the picture, and it's not a pretty one. I don't know about you, but that doesn't sound like the day at the beach that I'm looking forward to this weekend. So what can you do to help? Put trash in a trash can. Reduce your use of pesticides and fertilizers around your home and garden. Whenever possible, use non-toxic or less toxic methods to solve your pest problems. Also, watch your irrigation system and adjust it to reduce runoff. This can help reduce water pollution from pesticides, fertilizers, and soil erosion. By taking a few simple steps, you can have an enormous impact on improving and protecting the health of our watersheds. Remember, it's the water that connects us. For more information on how you can make a difference in protecting your watersheds, contact the San Diego County Watershed Protection Program at 858-846-0800 or visit our website at www.projectcleanwater.org.
Okay, thank you for watching that. I guess I have to hit escape here. There we go. So we can just as easily reduce the materials entering into the watershed. And with rain events like we're having today, we can't control those, but we can definitely control irrigation runoff. So the San Diego County Watershed Protection Ordinance specifically addresses the things we need to do to reduce that runoff. The WPO, or Watershed Protection Ordinance, states that residential discharges shall install and maintain best management practices and implement pollution prevention practices. Additionally, releasing pollutants directly or indirectly into the storm drain is a violation of the WPO. So to help you with implementation of those best management practices, or BMPs, in addition to what we discussed in the presentation today regarding irrigation, we'll be sending you an email afterwards, as Scott mentioned, with specific links to resources that you can utilize to help you implement the BMPs. One of those links will be the County Pollution Prevention BMP flyers. So they've created a whole set of flyers that give you very specific tools and ideas for implementing the BMPs. The benefit of best management practices, is of course avoiding pollution, but there are more benefits. Money saving, for example, and we know how expensive water in San Diego is. So managing our irrigation systems can help us to save money by utilizing less water. So we'll also send you some links about water conservation, the watersmartsandiego.org, and etc. You can also find your local water district may have other resources for you, such as irrigation system audits, and so on. So these resources, I hope, will help you address any issues that you may have, or help you to conserve water and save some money at home. One of the things closest to my heart is plant health. There's nothing like a beautiful landscape. Improper watering is the #1 cause of poor plant health. So managing our irrigation systems properly will improve the health of our plants. And I might add that landscapes can increase your property value. So the more beautiful your landscape, the more money saving or earning you might have. Some of the best practices for garden and landscape management include preventing pesticides and fertilizers entering the watershed, as you saw in the video. The flyers I mentioned just a minute ago include this information. So these are little snippets from those flyers. So I want to mention specifically some things about preventing pesticides and fertilizers from entering the storm drain. Apply the materials according to label directions and rates, and use the least amount of material that will do the job. More is not better when it comes to these materials. You can cause more harm than good to your landscape and the environment. Sweep up or clean up any spills immediately. Apply these materials when the wind is less than 10 miles per hour, so earlier in the morning or later in the evening. Try to avoid applications prior to rainfall or immediately before irrigation events, so that you're not washing off the pesticide. It won't do any good for the purpose that you applied it, and then of course it can end up as a pollutant. Spread your fertilizers evenly, and then make sure you sweep up any materials that landed on hard surfaces so they don't get washed off into the storm drain. And then the fertilizer application may require that you water it in. Make sure when you water in the fertilizer that there's no runoff involved in that process. And then we can use things like mulch to reduce the need for fertilizers. As the material breaks down, it adds nutrients to the soil and also can help reduce the need for herbicides in weed control. So again, we can't control runoff from the rain. You're noticing that today, or you've noticed that many times before, but we can manage the materials that we put on our landscape and make sure they don't enter the storm drain. We can also manage our irrigation systems. And so that brings us to the reason you joined us today, is to talk about irrigation management. So what can we do to utilize our systems to maximum efficiency and avoid runoff, save water, grow healthy plants, and all of those things? We can adjust our sprinklers so they don't spray under the streets and sidewalks, repair leaks and broken components. We can water in shorter cycles to allow the water to absorb into the soil. We call that cycle soak. We can water in the early morning or later in the evening when it's cooler and when there's, again, when the wind is less than 10 miles per hour. Excuse me. This makes sure the water actually gets applied to the landscape rather than blowing in the wind or evaporating into the air. And then, of course, you can replace turf. That's not a subject we're going to get into today, but some of those resources that we're providing, Water Smart San Diego and all of those kinds of resources may have more information about that for you. Okay, so our goal, of course, with managing irrigation systems is to irrigate properly and efficiently. So our goal is to direct water to the plants, to the root systems, and avoid watering things that don't require it, like hard surfaces, and not allowing that irrigation water to run into our yard drains. So the WPO, the Water Protection Ordinance, states that we do not allow materials from our yard drains to run into the storm drain system. That's not what our yard drains are designed for. So we want to make sure we're not allowing that material into those drains. The other thing another goal we want to keep in mind is to water when needed rather than on a set schedule. Now, later when I talk about automated irrigation systems, I'll talk about ways that those systems can be adjusted. So we want to water according to the needs of the plant, the soil moisture, and only water when the top 1 to 2 inches of soil is dry. So we can implement moisture meters that you can stick into the ground, or automated irrigation system controllers will have some sensors, or you can add sensors to your controllers. And I'll talk about that more briefly in a minute. And again, maximum plant health is going to occur with proper irrigation. So maintaining an even soil moisture according to the plant's needs and the season. Some plants require more water in winter, some require more water in summer. So we want to know what our plants require and water them appropriately, but maintaining an even soil moisture rather than fluctuating between heavy watering and drying out periods is much better for plants, and it will also help you to avoid runoff and erosion from watering heavily a dry soil, because you're going to experience more runoff on dry soils. All right, even the most simple irrigation system, and I call them manual irrigation systems, require maintenance, tools and parts that operate correctly, and knowing how to use it for maximum benefit and efficiency. So the best advice I can give you is to buy a good garden hose. There's lots of hoses out there, but find a good one. Use a hose reel to keep the hose from kinking. When you roll up the hose, make sure it's not kinked. Eventually those kinks will turn into cracks that then turn into leaks, and you're not getting maximum efficiency out of your hose. Try to store the hose in a shady place if possible to avoid breakdown from constant exposure to sunlight. And make sure that your hose reel, your nozzles, and all of those things have good seals, good fit for maximum operating pressure. So I have a picture here of these O-rings. Usually when you buy a hose, these O-rings will be present, or when you buy a hose reel or a nozzle. But check that, because sometimes they get removed from those parts or they fall out. So you want to make sure you have some spare O-rings around and use them properly. Make sure they fit the hose reel, the nozzle, etc. correctly. You're also going to, if using hose end sprinklers, as a manual type system of irrigating, make sure, again, you're avoiding the watering of hard surfaces by setting the sprinklers appropriately. So learn how the sprinkler operates and operate it correctly, and take a minute to set it properly. Cover your yard drains to avoid flow to storm drains. If you can't avoid getting water on, a patio or sidewalk or something like that, make sure your yard drains are covered so that that water does not flow into the storm drain. Something that is very helpful in utilizing both hose end sprinklers and drip systems, which I'll talk about later, are hose bib timers. These correctly connected to your hose bib or spigot in between the spigot and the hose can be set to run your hose and sprinklers to avoid allowing those sprinklers to run for too long. And you can also use them, when you're watering manually with your nozzle. You can figure out how much water do I need to apply to a particular garden area and set the timer before you begin watering by hand with the nozzle. And then if you're not going to use a nozzle, use a hose end shutoff. And these little gadgets here can be found in all garden centers and box stores. I recommend buying a good quality one. Again, make sure it has an O-ring. But when you're using things like this, these are helpful instead of like, bending the hose to stop the water or kinking the hose. That's going to put wear and tear on your hose. They have a shutoff, but don't leave your hose under pressure with the shutoff for more than a few seconds at a time, because that puts pressure on the system and could cause blowouts here and there. All right, automated irrigation systems. Again, we need to maintain these systems and parts in good order for efficiency and maximum benefit. So the first thing we want to do is understand our controller. So there's going to be a controller or a time clock that starts and stops your system. You want to make sure you understand the operation of that controller. I found this great video on the Helix Water District website, so we're linking that for you in the email following the presentation. So I highly recommend that, as well as using the operator's manual on your controller. There are lots of different controllers. I'll discuss a couple of different kinds, but you can also consider that hose bib timer as an automated controller. So make sure you understand how it works. Setting our controller is something we have to do, and we will periodically have to change the settings on these controllers. We're going to, again, set it to water as needed using various sensors. Again, I'll mention those in a minute. For seasonal watering requirements, sometimes you have dormant season lawns or lawns that go dormant in particular seasons. You want to make sure you're not overwatering them during those seasons. You're going to want to make sure you're not watering during rain events like we're having this weekend. And you also want to consider the requirements of your plants. So for example, native plants and drought tolerant plants need water at different times of the year versus water loving plants that may require more water during different seasons or throughout the year. So plan for your garden, landscape, trees, shrubs, and flowers to be grouped by similar watering needs in zones so that you can operate the zones using your controller to water the different areas of your garden and landscape as needed, rather than watering everything the same way, always on a set schedule. Simple controllers, as I said, like hose bib timers or battery operated types, can also be used with drip irrigation systems. And I'm going to talk about drip here, but even water conserving systems like drip irrigation can waste water and cause runoff if allowed to run for too long. So controllers, as I said, there's lots of different brands and types. So I want to take a minute here to just say that examples of anything I've included in the presentation is not an endorsement or a recommendation of any particular brand or product. These are just examples of what's available, and they all work in a similar way. So I've just chosen these to illustrate the points I want to make. So again, we can avoid overwatering by using some of the components that are either included in your controller or can be added to your controller. So weather sensors will help the controller determine if it's raining today, then I shouldn't water, for example. There are evapotranspiration sensors that will measure the evaporation from the soil and the water uptake and transpiration or water loss from the plants, and determine when water needs to be added. There are leak detection faults included in these clocks, so they'll stop the water if a leak is detected. You never want to override those faults because it's indicating to you that there's a problem in your system that you need to address. The great thing about these controllers nowadays, just like everything else, is that they can be used Bluetooth or wirelessly, and also with your smartphone. So let's say, for example, you're out shopping, your irrigation system comes on and it's raining and you want to shut it off, or it tells you there's a leak and you want to shut it off. So you can start and stop the irrigation as well. Let's say you're on vacation and you want to make sure that the water comes on at a certain time, all of those kinds of things. Again, we have to control or program the controller. So we're going to set the controller days to water for each program. So a clock like this, for example, may have 4 different programs, A, B, C, and D, and you can set the days that each program is going to water. So you can water Monday, Wednesday, and Friday, for example. But again, this is according to the needs of the landscape and garden at the time you're setting the clock. And then you're going to set the time to run each zone or station within the program. So this clock, for example, has station 6 through 18. And you can sometimes add more stations or zones to a clock, but this one can accommodate up to 18. And so you can run zones 1, 2, and 3 on program A, zones 3, 4, and 5 on program B, and so on. You're going to set these zones according to the topography, your soil type. So for example, let's say you're trying to irrigate steep slopes. You can use the cycle soak function on the clock to water in shorter periods of time with breaks in between to allow the water to soak into the soil rather than trying to get all the water on at once and having it run off and taking the soil with it. You're going to, again, pay attention to soil moisture and the needs of your plants. This controller here is battery operated. It works under the same concept. It has 1, 2, 4, or 6 zones, and I think up to 4 programs. It depends. You can buy them with 1 zone or up to 6 zones. And again, they're battery operated. I'll talk more about these in a minute here. So I think it's important to understand how an automated system works in order to manage it best. So I'm just going to briefly talk here about how a system like this is connected to your water supply line between the house and the water meter. We call this the point of connection, or POC. And this typically is galvanized or brass. Brass is better to avoid corrosion. And then there is a gate valve which can shut the water off between the irrigation system and the water supply line to the home. That's important to have. Then there's a backflow preventer, and there is a shutoff on either side of that. And this prevents water from the irrigation system moving backwards into your home supply or the municipal water supply. That is required. And if you ever had to have your home audited or permitted, you would have to have the proper backflow preventers or anti-siphon parts installed. So if you're not comfortable doing this kind of thing by yourself, then I highly recommend a professional. Then you're going to find a pressure regulator following the backflow preventer. And that's because the pressure typically coming from your supply line is higher than is necessary or required to run the irrigation system. So this pressure regulator should keep the pressure at 40 to 60 PSI, or pounds per square inch, going into the irrigation system. Water is held under pressure behind the valves. Now this system has a master valve included. This is a great idea because this master valve will interrupt any issues further down in the system. So if one of these valves here has a leak and doesn't shut off, the master valve can then turn the water off at this point in the system. Then you have more isolation valves before you get to the valves that operate the individual zones of your system. And these are good for shutting water off if you find a leak further down in the system. You can isolate, stop that water from flowing until you can repair the issue. Oh, and then of course the PVC pipe. This is the water delivery lines, right? This is the polyvinyl chloride pipe that distributes water throughout the system. And we're going to take a look at those here briefly in a bit. Okay, so then our program controller comes in, and each valve then in the system has a solenoid. That solenoid is wired to the controller. So you could see the wire bundle runs to each of these valves. As a matter of fact, the wire bundle should follow the irrigation pipe. So it's easily located and is sometimes also put in its own conduit pipe. So again, the solenoid is wired to each valve or zone on the controller. An electrical signal from the controller runs through the solenoid and opens the valve diaphragm, and water flows through the valve into the PVC pipe. A similar concept works to operate your hose bib timers, right? It allows the timer triggers, I'm sorry, I can't think of the word, a valve to open and let water flow into the hose. So it's all the same concept. So the flow of water, right, is regulated by pressure, and then the flow of gallons per minute or gallons per hour, depending on what type of system you're using. The pressure or flow rate required to run a system is determined by the sum of the flow rates of all the outlets downstream of a particular valve. So basically what that is the number of sprinklers or maybe emitters in a drip line and the distance that you're trying to push that water. So again, if you're not comfortable designing and building a system on your own, I highly recommend a professional. We are going to provide you with some resources for designing and building a system. There is a lot that goes into a system, including calculating pressure, the math, and all of that, and understanding how water moves through the pipes and so on. But if this is something you're interested in doing, it's definitely doable. But if you're not comfortable, definitely I recommend a professional. Keep in mind that slopes will either increase or decrease pressure depending on whether the line's running up or down. So that can also affect the operation. I wanted to talk briefly about the types of automated systems. Basically, there are two. There's sprinkler irrigation and drip irrigation. Drip is an umbrella term that's also used for other types of micro irrigation. So I'll mention those as well here in a little bit. But I wanted to compare sprinkler to drip. So sprinkler irrigation broadcasts the application of water. You're going to have the potential, as I mentioned before, to have reduced efficiency due to wind and evaporation because the water is spraying out, whereas drip is a direct application of water to the soil directly at the root zone if it's set up properly. So you don't have that impact from wind and as much evaporation, and you're going to get fewer weeds potentially with a drip system because you're not watering, you're not broadcasting the water. Sprinkler irrigation requires that the pipes are buried, so the trenches have to be dug. but that usually results in fewer repairs. With drip, you don't have the digging, but you're going to damage the drip. If you're active in your garden, or you have pets or children or grandchildren, you're going to be doing more repairs, damage from tools, and so on. Sprinkler irrigation can compact soil over time. If you use this water cycling or cycle soak, you can reduce that the issue from that, right, by applying less water in multiple applications. With drip, you're not likely to get any soil compaction. The coverage with sprinkler irrigation is a better reach and probably better uniformity. Although if the system is not built properly, you can definitely have issues with uniformity. So I'll talk about that briefly. Coverage with drip is obviously you're just putting water directly onto the root zone, but soil moisture consistency is important because water needs to move laterally through the soil as well as downward. And with drip systems, you can sometimes have issues with that, where the water is going straight down into the soil and not spreading out, so that the entire root system is getting a good water. So again, consistent, even soil moisture is important if you're using drip. Sprinkler irrigation is good for leaching salts, so you don't get, the brown tip burn and things on some of your plants. And drip irrigation is not good on all soils. It doesn't really leach. For example, if you're trying to use drip on a sandy soil, you're not going to have that good lateral movement through the soil. You can use sprinkler irrigation to keep dust off of your plants, reduce incidence of pests and things like that. You can't do that with drip, but drip is better in cool weather to avoid diseases that can be caused by water on the leaves, causing foliar and fruit diseases and things like that. So pros and cons of both. Whatever your preference, the important thing is to use them correctly for efficiency and biggest benefit, and to avoid runoff. So drip irrigation is typically used in non-lawn areas. We're targeting water at the root zone. You can connect a drip system to your hose bib or spigot. You can connect it directly to a valve, or you can retrofit to sprinklers. So you can combine a sprinkler irrigation system and drip systems on the same controller, but not in the same zone. And I'll try to make that more clear here in a few minutes. The output design for drip is basically the same. We're looking at pressure and flow rate, but we're measuring in gallons per hour versus gallons per minute. And the output is based on the number of emitters that are in the run, or the distribution tubing, the length of the tubing that you're deciding to use. Different emitters put out different amounts of water. So some drip tubing may have emitters spaced every 9 inches and have an output of 0.09 gallons per hour. Different combinations and different types of drip systems. The drip system you want to use is going to be dependent on whether you're putting it in before you plant or after you plant. And so emitter spacing obviously is going to be important to make sure you have enough emitters delivering water to the plants you're trying to irrigate. You have to have sufficient pressure to run the distance and the number of emitters in the line, in the distribution tubing. So you can check what is the maximum recommended length for a typical pressure setup. Most drip lines will require 10 to 45 psi. So again, you're probably going to need a pressure regulator in between the water connection and the drip line, because pressure coming directly into your supply line is usually much higher, somewhere around 70 psi. Again, you're going to have tools and parts to repair damage from tools, foot traffic, animals, and so on. Some of the drip system options: you can buy a blank tubing and insert your own emitters. This is called a spot watering emitter, or you can connect a tube, and then with a guard at the end, the water drips out at the end. So you have to use these stakes versus an inline emitter. So different systems, you can set it up. This is more beneficial to use when you're installing drip in a landscape that's already developed. This is good to use when before you've installed your plants. It can be a little challenging to get this into an existing landscape. It can be done, but you're going to have to make sure that the emitters are delivering water where you need them, to. Let's go over here to multi-port emitters. This cap is connected to the water source, and then it has multiple ports that you connect the tubing to. And again, sometimes you stake that, sometimes you don't have to, but those stakes can get broken if you're spending time in the garden or you have pets, things like that. My dog loves to chew on things like this, so I'm very well aware of how many times I've had to repair that. And then micro spray. These are sort of a combination sprinkler and drip system. So they do spray water, but they deliver less water through the 1/4 inch tubing than you would get from a traditional automated irrigation sprinkler. But these are great for watering trees, fruit trees, and so on. If you have small orchards or even a large orchard, this is something you might want to look into. And then you can convert your sprinkler system, your sprinkler heads, to a drip line. There's a couple of different ways to do that. Again, there's lots of parts involved. They're fairly easy to do, but you just want to make sure that you have good connection and no leaks for operating an efficient system. All right, so lots of parts involved in a drip system. There are parts involved in a traditional sprinkler system as well, but you're going to be replacing and repairing your drip system typically more frequently depending on how it's used. So you need a supply of these parts and the tools. For example, a cutter for cutting the tubing, and these line ends, or I call them figure eights, that you bend the tubing over at the end, and this closes it off so the water just doesn't flow out the end of the tube at the end of your line. And then if you're punching in your own emitters, it's very helpful to have that tool there for that punch. You can connect the drip directly to your hose bib or spigot. I'll talk a bit more about that. You can put a timer in between the spigot and the drip line. You're going to need some adapters for that. Or connect the drip directly to a valve that's operated by an automated controller. So some basics about drip installation. You're going to probably want a low flow valve if you're connecting directly to a valve. As I said, the pressure required to run drip is much lower than it is for a traditional sprinkler irrigation system. And then you're going to use a filter and a pressure regulator. You can buy all of those things in a kit together, or you can buy them separately, the valve, filter, and a pressure regulator. You can also install splitters in at the beginning of the line with shutoffs after the pressure regulator, so you can run, multiple lines off of one valve. You're going to want to run the tubing within 3 to 5 feet of plants to be watered if you're using the punch-in emitters. And then if you're using the inline emitter, you're going to want to run that drip line very near the root zone of each plant. The emitters in some types of drip systems are color coded for flow rate, so you know how much water you're putting out of each emitter. And then of course, the punch-in emitters consist of the tubing and the stick. This is an example of a shutoff. If the handle of the shutoff is parallel to the tubing, then it's open, it's letting water flow. You turn that perpendicular to the tubing, of course, it shuts off the water. And that's true for gate valves and ball valves, isolation valves, and all of that kind of thing in a traditional sprinkler system as well. So here you can see the drip line is connected to a hose bib. There's a backflow preventer, a pressure regulator, and a filter. And then there's an adapter to connect the tubing. Here you can see a similar setup. I wanted to point out that you can use a pressure regulator or a pressure reducer. The pressure reducer is going to take the pressure down to a set PSI. A pressure regulator has a bolt that you can adjust the pressure. The pressure regulator is a little more expensive, but you might like having that adjustment option. Make sure when you're installing these things that you're installing them with the arrows that are stamped into the parts with the arrow pointing downstream to match the direction of water flow. If you get it in backwards, the water won't flow. I've done it before, so I know. It's easy to do. You got to watch that. Okay. This is a typical inline emitter drip system connection to a valve. So this is a kit. I use these in the raised beds here at Miracosta College for growing vegetables and all kinds of different things. We happen to be growing potatoes in this bed. And you can see we're using the battery operated controller. And this controller has two zones. And you can see there's 2 red wires. So one red wire for zone 1 is connected to one valve, and the wire for zone 2 is connected to the other valve at the solenoid. This is the filter here, and then the pressure regulators are the white ones. These are actually pressure reducers because we're running these at, I think, right at 45 PSI on those. So this pipe here then is connected to our main water supply back here on the other end of the system. And you can see where you connect the drip tubing to the pressure regulator or reducer. And then we have it bent here at a 90-degree angle with an elbow. And then it branches off here. So we have this line runs off in that direction, a middle line, and then a third line running off to the right. This valve is controlling a different type of drip system outside of the raised bed, where we're using punch-in emitters to water individual containers. When you're using a battery operated controller like this, you're going to use a particular type of solenoid. It's different than the solenoid that may be used in a traditional electric controller. Because of the way the solenoid works, in a traditional electric controller, the solenoid sends a constant signal, or I'm sorry, the clock sends a constant signal to the solenoid sending a constant signal to the valve to keep it open. And then when it closes, the signal stops. In a DC latching solenoid, which is used with the battery operated controller, it requires one burst of signal to open, and then it remains open. That solenoid keeps the valve open until it receives the second signal. So it doesn't require that constant signal from the clock. It'd be so that you're not, utilizing the batteries too much and having to replace them too often. Okay, moving back to our automated sprinkler system parts, I wanted to point out again, here's your valves. You'll notice here that this system has traditional sprinklers on these two lines, and then over here is a drip system. So we have these separated into 3 zones. So your controller is going to run this zone separately from this zone, and then separately from this zone. And that's what's great about an automated system, is you can run these systems at different times separately for different lengths of times, for different types of water. You can put different types of sprinklers on different zones and so on. So this system consists again of the PVC pipe. Typically the line coming into the valve is going to be between 1 inch and 1/2 inch. The line coming out of the valve and distributing water is about 1/2 inch, and typically schedule 40. It depends. But my point here is that if you're going to repair a broken PVC line, you want to use the same schedule that the original line was made of, right? So don't use a different schedule pipe. They're going to have different wall thicknesses. It's going to affect pressure and all of that. So use the same schedule. And again, there's the isolation ball valve that you're going to want to shut the water off before you make any repairs to your system. Your PVC joints are either threaded where they screw on, or they're a slip where the pipe slips into the coupler or the joint, and those need to be glued. So we use 90 degrees angles, usually slip, but they can be slip on one end, thread on another. It just depends. 90 degrees for those corners, and then the T's, right, for your lateral lines. I'm going to talk a bit about swing joints on your sprinkler heads, because I think they're a great idea. They reduce breakage, and they give you much more flexibility in placing your sprinkler heads. So a sprinkler head or body consists again of multiple parts. This is a pop-up, so the water comes through the inlet under pressure and pops up the riser. The nozzle is attached to the top of the riser. There's a seal in here so that when this shuts down, water doesn't continually pour out. And then there's also a check valve. It's optional on sprinkler heads or bodies. I recommend that you have them at the within the system at the lowest point in your system, so that when the water drains backwards or down to the lowest point in the system, it doesn't flood out of that sprinkler at the bottom. The check valve will keep that from happening. Okay. And then the nozzles can be removed from the body. They can be replaced. You can change them out. There are many options for nozzles. I'm going to show you some of those options. They're designed for specific use, however. So a specific nozzle is designed for a specific use. You can also get nozzles that have a radius of 360 degrees, 180 degrees, or 90 degrees, or you can adjust that spray pattern. So let's go here. All right, so here's a synopsis of our entire system. I talked about how it's connected to the water supply. Here's your controller mounted somewhere on a wall or a post. The controller should be in a protected environment. If it's not, make sure you always keep that door closed so that the circuits and the components aren't exposed to the elements, as well as the digital display on the clock. The sun can do damage to those, so keep that door or lid closed on that controller. Here's your wiring connected to the various solenoid valves, and you can see here again we have 3 zones. This zone is using a particular type of sprinkler called an AccuSync 50 automatic. And this zone over here is using an MP rotator Pro spray. It's a Pro spray body with an MP rotator nozzle. So again, you can use different sprinklers or drip on different zones, but you have to keep each zone the same. So this zone always has to have the same type of sprinkler. This zone always has to have the same type of sprinkler. And that's because, as I mentioned before, the pressure required to run the system is dependent on the outputs, right, throughout that system. So different sprinklers use different amounts of water and require different pressure ratings. So it's important that you keep your zones consistent in their parts. So we're going to send you, we're going to send you this whole list of resources. I hope they are useful. Again, this is not a recommendation of any particular brand or industry supplier. It is just a list of resources that are representative of what you might find. By all means, do your own investigation. But these are things we thought might be helpful to at least get you started and moving in that direction. One of the things I do like is that you can take classes, and that one of these is a series of videos. Here it is, all about sprinkler systems. So you can watch one video at a time, or you can watch the entire series, and they're very, very helpful. So look for that kind of thing whenever you have issues arise. All right, so again, back to one of our BMP flyers, right? We're going to send you a link to these. I hope that you'll bookmark them on your computer or print some of them out for easy reference, because they really will help you to not only reduce runoff, but help you to use your systems and manage your gardens and landscapes more efficiently. So remember, we cannot let runoff leave our property. Irrigation runoff. The rain runoff you have no control over. It's the irrigation runoff we have to control. So how are we going to best utilize our system? I mentioned earlier doing an audit. Now, you can do a very extensive audit on your system, but I'm not going to go into that. If that's something you're interested in, you can go to the Irrigation Association. We'll send you a link to that. And they have a whole tutorial on how to do an audit, including all the forms and tables and things that you can utilize. I do recommend that you do some organizing for yourself by creating some sort of record of your first audit, and then repeat the same system every time, because it'll tell you if there have been changes at particular places in your system. So for example, you're going to run your system for a specified time. Don't run it to runoff, but run it for, let's say, 5 minutes. And you're going to, before you start the system, you're going to put out collection cans, and you want those cans to be the same size and shape. So you can use square plastic sandwich containers, or old pickle jars, whatever it is you want to use. The bigger the opening, the better on the collection can. But you're gonna place those collection cans, one at each sprinkler, and then in between every sprinkler. And you want to use as many cans as possible. In other words, more cans is better than fewer, but it's up to you. And then operate your system. So what you're checking for is that your pop-ups or your sprinkler heads are operating correctly, that the nozzles are operating correctly, and that the output patterns are correct. So we're looking at the arc, which is the pattern at which the sprinkler sprays. Is it supposed to be 90 degrees or is it supposed to be a full 360 degrees? And then the radius or the distance that it's throwing. And we want head-to-head coverage. We want the coverage from this sprinkler to overlap the coverage from this sprinkler. So that's so that you don't have those big gaps in between. Is gonna sort of make you think you need to run your system longer, and that's not really what you need. You just need better coverage. You need the sprinklers to either be closer together, or you need different sprinklers that will cover that distance and overlap. If you don't have check valves in place, you'll know it. When you shut the system off, you'll see the water bubble up from the sprinkler at the lowest point in the line. And that will tell you need to get a sprinkler with a check valve in it. If you know you have check valves in place, make sure they're working. If they're not, then you need to replace it. And then observations. Is runoff occurring and why? Is it running off because my soil is so compact? Is it running off because I need to adjust the sprinkler pattern? Is it running off because there's a plant in the way and it's forcing the water backwards onto the sidewalk or the curb or something like that? So your audit should inform adjustments, maintenance, and repairs. So again, keep a record of this and operate your audit the same way every time so that you can see changes. So you'll want to go back to your collection cans and look at the amount of water in each can, and that will tell you how is your system uniform or not. Is it putting out the appropriate amount of water throughout the system, or do you have spots that are putting out more and others that are putting out less? And then you can make adjustments or changes to your system accordingly, so you get better uniformity. Okay, so again, once you've done your system audit, you may adjust your run time. You may want to run multiple times in the cycle soak function of your clock, or just set your zone to come on more than once a day. You can do that with the automated controllers. Most automated controllers allow that function. Check your sprinkler body height. Is the pop-up coming up to its full capacity? Is there enough pressure to push it up? Or is the body too low in grade? Do I need to add a bigger, taller pop-up? Or do I need to use a stationary riser with a stationary sprinkler at the top to get over some of those plants that have grown too high? Or do I just need to do some plant maintenance and do some pruning? So there are options for the way you set up your system. Do I need to take my sprinkler nozzles out and clean the filter inside there? Do I need to replace the nozzle? And so on. So the other thing you might find out is that you need more efficient nozzles. So I'm going to show you a brief video here. I think it's 2 or 2.5 minutes on some options for efficient nozzles. I apologize if the music at the beginning of this is a little startling, but let's see how it goes.
Conserving water can be as easy as retrofitting an existing sprinkler system with efficient nozzles. Depending on the nozzle you choose, you can reduce water consumption by as much as 30%. There are many options to choose from, each with their own benefits, but one common aspect is that each nozzle features matched precipitation rates. This means the speed at which water is being applied to a specific area will not vary regardless of how the nozzle is adjusted. Another great benefit is the plant materials evenly watered at a rate slow enough to allow the water to be absorbed into the soil, reducing runoff. The first option in our efficient nozzle roundup is the MP rotator from Hunter. This line of nozzles features an adjustable arc and radius. Depending on the nozzle selected, it can cover from a 5-foot strip up to a 35-foot radius. The MP rotator is equipped with its own protection mechanism that keeps the nozzle free and clear of debris while not in operation. This double pop-up action features a spring-loaded nozzle, which is stronger than the pop-up spring. This keeps the nozzle in the retracted position as the system is being activated. Once the cycle is complete, the nozzle retracts to be protected until the next cycle. The Toro Precision Rotating Nozzle is another efficient option. Powered by a proven gear drive, it delivers wind-resistant, multi-stream, multi-trajectory patterns. It has a 45 to 360 degree arc, which is adjustable by hand or with the included adjustment tool. The gear drive mechanism delivers a consistent speed of rotation regardless of system pressure and prevents the product from stalling at low pressure. This hand-adjustable rotary nozzle is the Rainbird R-Van. The spray pattern and distance are easily adjustable by hand with no tools required. The arc can be adjusted from 45 to 270 degrees and distance ranges from 13 to 24 feet depending on the model you select. If you prefer spray nozzles to rotators, there are a couple of great options to choose from. The Rainbird HE Van is available in 8, 10, 12, and 15-foot radii and is adjustable from 0 to 360 degrees. It's the only variable arc spray nozzle on the market that changes the flow with the arc to maintain matched precipitation rates across all models. With exact edge technology, an adjustment mechanism you can feel click, the HE Van takes the hassle and guesswork out of getting a clean spray pattern edge. Another efficient spray nozzle is the Toro Precision Spray. Using patented H2O chip technology and no moving parts, each Precision Series spray nozzle creates one or more high-frequency oscillating streams to achieve the desired arc and radius. The H2O chip generates a larger, more uniform droplet size, resulting in consistency across the irrigated arc. Whether you're installing a new sprinkler system or retrofitting an existing system, high-efficiency nozzles will help you save water and money. All the products we've discussed can be found at your local Ewing branch, or you can also order online at ewing1.com.
Okay. I hope that was informative. You'll get a link to that. I realize we're running short on time here. I thought I would go a little bit faster. I apologize for going past our 11:30 time, but I'll do my best to finish up as quickly as possible here. So again, other adjustments you can do to avoid runoff is to take that nozzle out of the sprinkler and clean that filter. Or as you saw in that video, there are many ways to adjust the nozzle or change out nozzles for better efficiency. He mentioned this particular nozzle. I'm gonna skip this video real quick because I can show you here, and as he also mentioned, this nozzle is adjusted with the adjustment ring and the radius adjustment screw. So there are lots of options for nozzles out there, and you can see or you heard the technology that the industry is putting into producing efficient nozzles that conserve water and avoid runoff. He also mentioned that some nozzles require tools to make the adjustment. So make sure you keep those tools, or if you need the tool, you don't have it, you can take the sprinkler head into a supply store and they can probably supply you with the tools to do your adjustments. Again, these require tools. I wanted to point out here that every sprinkler nozzle gives you some information that tells you about the way it operates. This is a 3090 to 210. So its throw distance is coded at 3,000. That's particular to this company's nozzle. That may throw, I'm sorry, I can't remember. It may throw 15 feet. I don't recall, but you can adjust the pattern from 90 to 210 degrees. And then also you can see here, this sprinkler body has a check valve in it. So the information stamped on these parts is helpful to help you in replacing them or changing them out if you need something different. You can take the parts to a distributor and they can help you with that. Okay, tools and materials for making repairs. If you're going to have to dig out the body or do some digging to repair a sprinkler line, PVC pipe, you're obviously going to need a shovel, but I highly recommend a trowel. I can't tell you how many times I've seen a sprinkler or the PVC pipe broken or cracked because of vigorous digging with a round point or trenching shovel. So I recommend a trowel around sprinkler bodies. You're going to need a larger shovel to get started, but when you get to the broken sprinkler line underground, then start using a trowel. Dig out enough space to work, and then clean off the part so you can see where the water is leaking. You don't want to shut the water off to the system until you've determined where the break is, and then go to your shutoff valve or your isolation valve and turn the water off to make the repair. You're going to want a tarp or burlap or something to put the soil or sod on that you take out from the hole so you don't throw it onto your grass and then have to deal with trying to get it out and back into the hole. You're going to want a PVC pipe cutter if you're cutting pipe, and some rags. The materials you're going to need to make repair could include PVC primer and glue, which you can buy in a combination package. You will not need glue for sprinkler body repair. Your sprinklers should not be glued into the PVC connection. And I'll show you what that looks like real quick. The only place you need glue is when you're making repairs to the PVC distribution line itself. You may want to install flex joints or swing joints if you don't already have them on your sprinkler body, or maybe those are the parts that got broken and need to be replaced. And then of course you're going to want to have the parts handy that you're repairing or replacing. So this is a swing or flex joint. You can see here that it's connected to the T coupling in the PVC line, the distribution line. And then this is a fully articulating swing joint here. Not all swing joints are created equal. I recommend the fully articulating one because you can raise and lower this body. You can swing it around. You can lift it straight up. You have a lot of flexibility. And what this allows for is that your irrigation pipe is typically buried deeper than you want your sprinkler body. So you can raise your sprinkler body to grade, right, where you want the water to be delivered when your PVC pipe is buried much more deeply. And then this also allows flexibility in the swing joint if you hit this body with the mower or you step on it or something like that. So you have a lot less breakage at the connection. If your body is connected directly to your PVC, that's when you sometimes are breaking those and they leak down here underground and you don't understand why you're not getting good performance out of that sprinkler body. Another quick video here on making repairs. This is using a compression coupling, but he does mention some other couplers. This one does not require glue, but some of the others do. So let's take a quick look at this.
In this segment, I'm going to talk about some of the common products that are used to repair broken PVC pipes. In this case, we have what's called a bolted repair coupling. This is used to repair large PVC main lines. Here we have a product called a slip fix. This is a real good product if you have to work in a very tight area. It gives you a lot of flexibility with your repair. Here we have a common 3/4 inch slip coupling. These can be used for real simple repairs if you're able to lift the pipe up enough to just use the slip coupling. Here we have the bell end that is commonly available on PVC pipe. Many times you can use the bell end as a slip coupling in making a PVC repair. Here we have a compression coupling, and I'm actually going to demonstrate a repair with a compression coupling and talk about the features and benefits of using the compression coupling. I'm now going to demonstrate how to repair a broken PVC line using what's called a compression coupling. A compression coupling has a lot of nice advantages. First of all, you don't have to use any primer or PVC cement to install the compression coupling. Also, it doesn't matter if you have water dripping out the pipe. So to make a repair using the compression coupling, we're first going to unscrew the end. We have the compression end and a gasket inside of it. We're going to go ahead and install that on one end of the pipe. And kind of center the compression coupling over your brake. We take the other compression end off, and here again we have a gasket inside of there. We're going to install the compression end on the other piece of the pipe and install our other grommet or gasket. The final component of the compression coupling is the sleeve. We're now going to center the sleeve over the area where the repair is and then simply tighten the compression ends until they're tight. And that's all we have to do to make a repair using a compression coupling.
Okay. One of the things I want to point out about making that kind of repair, as I said, you're going to dig it out, clean it off, find out where the leak is. Then you're going to make clean cuts on either side of that break or crack. When you slip in your coupling, whether you're using a compression coupling or a coupling that needs to be glued, make sure you don't put too much pressure when you lift up the pipe to fit the coupling on, because you can cause cracks on either end, right, where that line is still buried underground. So dig out enough room to give yourself to work and not put too much stress on those PVC lines. That's the majority of the presentation. I do want to remind you that we're all about avoiding runoff and watershed pollution. So don't allow that irrigation water to run into the storm drain or into your yard drains, carrying polluting materials with it. We all live in San Diego. We know there's a lot of slopes, is what I'm trying to get at here. So if you do have sloping yards or areas in your yard where soil erosion and runoff is an issue, you can use sandbags, fiber rolls, or straw wattles, and mulch. Mulch is a great way to keep soil from eroding off of bare soil, or plants that will spread out their root zones and help keep the soil in place. But try not to let that soil run into the storm drain. What can you do? Redirect your sprinkler heads, as we've discussed. Use dry methods such as sweeping to clean your yard and patio. Hose down items such as patio furniture away from your yard drain or cover your yard drain. Water in short cycles to allow that water to absorb into the soil. And avoid application of fertilizers and pesticides prior to rainfall. And as we discussed at the beginning, apply them appropriately and correctly. Remember, it's the water that connects us. We all depend on our water resources. And I hope you found this this presentation useful and informative. I hope you get some use out of the resources you'll be receiving afterwards. But if you do have questions, we're going to hang around here for a few minutes. But I also wanted to provide these useful phone numbers. If you need pesticide disposal, we have some master gardeners here helping us today from the University of California. They have a hotline if you have questions about today's presentation or pest management issues and so on. And I want to thank you for joining us. Please do complete the survey. Let us know how we did and what we can do to improve. And then look for us later on this month and in the months following when we'll have more workshops. I'm going to stop sharing my screen and invite our master gardeners and Scott to come back, and let's see if we have any questions.
We do, Carolyn. Thank you. That was an awesome presentation.
Great.
I'm not sure. That's okay. I'm not sure if we answered Andrew's question. He said, how do you find a leak in our water line? So is there anything you want to expand on?
Great.
Or Andrew, was that answered?
No,
No.
I don't think it was.
No.
That's a great question, and thank you for asking it. So there are leak detectors out there if you want to invest in that kind of equipment. But typically, if you have a cracked or broken PVC line, it may take some time to show up, but eventually the soil in that area is going to be very wet. It's not going to dry out like the rest of your landscape or garden. And if it continues for any length of time, you may start to see water actually coming to the surface, depending on how bad that crack or leak is. So once you find that happening, you're going to have to dig. You're going to have to get your shovel out. Most irrigation lines are somewhere between, oh gosh, I've seen them as shallow as 8 inches. I've seen them as deep as 12 or 16 or 18 inches. So you're just going to dig until you find that pipe. And if the line is still under pressure, which it should be when you're doing the digging, you'll be able to see where that leak is coming from. And then you can dig out around it, give yourself some room to work.
May I ask some questions?
Carolyn, would you also be able to, would an indicator of where the leak in the system might be, looking at the way the water distribution is supposed to be throughout all the sprinkler systems, and if you're seeing something that seems out of the ordinary down the line, that would give you an idea to come back up as to where the lines are to start your investigation?
That's a great point. A great point. Are you concerned that you're using too much water and you're not sure why? Is that, I'm curious as to the reason behind